All right, let's talk, people. Imagine a world where the only thing you've ever known is computer code, algorithms, data structures, maybe a little machine learning on the side. It's a world of logic and precision, but is there something missing? What if I told you that philosophy, the OG thought experiment, holds insights that can make you a better computer scientist? Don't believe me? Well, my friends, that's what we're here to explore today. The line between philosophy and computer science might seem thick as a firewall, but trust me, it's more porous than you think. Philosophize this. It's about questioning assumptions, thinking critically, and getting to the core of what we think we know. Those skills, they're just as crucial for writing elegant code as they are for dissecting the works of Plato. So, buckle up, computer scientists. We're about to embark on a journey through the history of Western thought, tracing a lineage of ideas from ancient Greece to the Silicon Valleys of today. We'll explore how philosophical inquiry laid the groundwork for the very logic that underpins our digital world, and how grappling with these timeless questions can make us not just better programmers, but better thinkers.
Our story begins with Thales of Miletus, often hailed as the first philosopher in the Western tradition. Imagine a world where myths and legends ruled, where gods and monsters dictated the whims of nature. That was the world Thales inherited. But Thales dared to ask a different kind of question. Instead of attributing natural phenomena to the whims of the gods, he sought natural explanations. He looked around and asked, "What is this world made of?" His answer? Water. Thales was after a unifying principle, a single element that could explain the multiplicity of the world around us. He observed that water was essential for all life, that it could take on many forms, solid, liquid, gas. And he concluded that perhaps, just perhaps, water was the fundamental principle. Thales shifted the conversation from the realm of myth to the realm of reason, of logos. In a way, Thales was like the first programmer trying to crack the code of the universe. Thales' idea of a fundamental principle, a unifying element, resonated throughout the history of philosophy and science. Because at its core, computer science, like philosophy, is about understanding the fundamental principles that govern complex systems.
Now, let's meet Anaximander, a student of Thales, who took his teacher's ideas in a bold new direction. Anaximander was not content with simply accepting the established notions of his time. He sought to push the boundaries of understanding even further. While Thales proposed water as the fundamental principle, Anaximander argued for something more abstract, something he called the apeiron. This concept was revolutionary, suggesting that the universe was born from an infinite, indefinite substance. Imagine a boundless, undefined, primordial substance, a kind of cosmic soup from which all things emerge and to which they eventually return. This idea was a significant departure from the tangible elements like water, earth, and fire that were commonly thought to be the building blocks of reality. Anaximander's boldness didn't stop there. He also speculated on the origins of life, proposing that the first humans were born inside fish, gradually adapting to life on land. This was a radical idea, suggesting a form of evolution long before the concept was formally introduced. Anaximander's notion that life arose in water and gradually transformed to inhabit different environments foreshadowed the theory of evolution by natural selection centuries before Darwin. His ideas hinted at a dynamic process of change and adaptation. He understood that change was not merely possible but fundamental to the very fabric of existence. This insight was profound, recognizing that the universe itself is in a constant state of flux. Anaximander's emphasis on change, on the dynamic and evolving nature of reality, has profound implications for how we think about information, about systems, and about the very nature of computation itself. His ideas resonate with modern concepts of adaptability and transformation. What is software development if not a constant process of adaptation and evolution? Just like the natural world, the digital realm thrives on continuous improvement and innovation. Programs that are flexible, that can be easily modified and updated, are the ones that stand the test of time. This mirrors Anaximander's vision of a world where adaptability is key to survival and success. Anaximander's legacy reminds us that change is not something to be feared, but embraced. It is through change that we find new opportunities and pathways to progress. It's the driving force of innovation, the engine of progress. Embracing change allows us to harness its power and drive forward into the future with confidence and creativity.
Hold on tight, because we're about to dive into the rushing waters of Heraclitus, the ancient Greek philosopher who saw the world in a way that still resonates today. You've probably heard the saying, "You can never step into the same river twice." Well, that's Heraclitus in a nutshell. He believed that everything is in a state of constant change. He believed that the universe is in a constant state of flux, that change is the only constant, and that everything is in a perpetual state of becoming. Nothing ever stays the same. Imagine a river, its water constantly flowing, never the same from one moment to the next. Each drop of water is different, each moment unique. That's my vision of reality. I saw the world as a dynamic interplay of opposing forces, a cosmic dance of creation and destruction. I saw the world as a dynamic interplay of opposing forces, a cosmic dance of creation and destruction. This constant change is what makes life vibrant and full of possibilities. I believed that there was an underlying order to this chaos, a kind of cosmic intelligence I called the Logos. This Logos is the reason behind the constant change. The Logos wasn't a personal god, but rather a principle of order, a kind of universal reason that governed the flow of change. It was the logic that made sense of the chaos. Think of it like this. Imagine a computer program that's constantly updating, constantly evolving. The code itself might be changing, but there's an underlying logic, a set of rules that governs how those changes occur. The code itself might be changing, but there's an underlying logic, a set of rules that governs how those changes occur. This is similar to how the Logos operates in the universe. In a world of constant change, information is not static, it's dynamic. It's always evolving, always adapting to new circumstances. It's about being adaptable, about being able to learn and evolve as the world around us changes. Just like a river, we must flow with the currents of life. So, the next time you're debugging code, remember me and my river of change. Embrace the flow, adapt to the current, and you might just find yourself riding the waves of innovation. Embrace the flow, adapt to the current, and you might just find yourself riding the waves of innovation. In the end, it's all about finding harmony in the ever-changing river of life.
Hold on to your hats, folks, because things are about to get really meta. We're about to meet Cratylus, a student of Heraclitus, who took his teacher's ideas about change to a whole new level. Heraclitus believed that everything was in flux, but he still thought there was an underlying order, a logos, that governed that change. I, on the other hand, took a more radical stance. I argued that if everything is constantly changing, then it's impossible to say anything definite about anything. Think about it. If the river is constantly flowing, how can we even point to it and call it the river? By the time we finish the sentence, it's already different. I believe that language, our very means of describing the world, was fundamentally flawed, unable to grasp the true nature of reality. Think about the challenges of representing the world through data, through code. We're constantly trying to create models, abstractions, that capture the essence of something, but there's always a gap between the representation and the thing itself. My legacy is a reminder to approach our work with a healthy dose of humility, to be mindful of the limitations of our tools, and to never lose sight of the gap between representation and reality.
Hold on to your atoms, folks, because we're about to meet the godfather of atomism, a man whose groundbreaking ideas laid the essential groundwork for centuries of scientific progress, Democritus. Imagine a world where the fundamental building blocks of reality are tiny, indivisible particles, constantly bouncing around in the void, colliding and combining to form everything we see and experience in our daily lives. That, my friends, was my vision. A vision that remarkably foreshadowed modern atomic theory by over 2,000 years, long before the advent of modern science. I believed that everything in the universe was made up of these tiny, indivisible particles I called atoms, which means uncuttable in Greek, emphasizing their fundamental nature. These atoms, I argued, were eternal and unchanging, moving about in an infinite void, a concept that challenged the philosophical norms of my time. The different forms and qualities we perceive in the world, I believed, were simply the result of different arrangements and motions of these atoms, creating the vast diversity of nature. My idea of atoms was revolutionary, a radical departure from the prevailing wisdom of my time, which often relied on more mystical explanations. My atomism, my emphasis on the discrete and the quantifiable, resonates deeply with the very foundations of computer science and modern technology. Think about it. At its core, computation is about manipulating discrete units of information, bits, which can be thought of as modern-day atoms of information, fundamental to our digital age. Just like my atoms combined in different ways to create the diversity of the world, so too do bits combine to form the complex data structures and algorithms that power our digital world, driving innovation and progress.
So there you have it. A whirlwind tour through the minds of some of the earliest philosophers in the Western tradition. We've journeyed from the watery depths of Thales's monism to the atomized universe of Democritus, encountering along the way the ever-changing river of Heraclitus and the skeptical silence of Cratylus. You might be wondering, what does all this ancient philosophy have to do with the modern world of computer science? Well, my friends, these early thinkers, with their relentless curiosity and their willingness to question everything, laid the groundwork for the very logic and reason that underpin our digital age. They taught us to look for patterns, to seek underlying principles, and to never stop questioning the nature of reality itself. And in a world increasingly shaped by algorithms, artificial intelligence, and the ever-expanding frontiers of technology, these ancient lessons have never been more relevant. So the next time you're writing code or designing an algorithm, remember the legacy of these philosophical pioneers. For in their wisdom, we find not just the roots of our digital present, but perhaps even a guide to navigating the complexities of our technological future.